consolidated 39 MV72 is the undisputed leader in performance and efficiency. The adjusting screw is used to compress the spring, which is the main force determining set pressure. The adjuster bottom requires rotation in or out of the base to position the exhaust seal relative to the supply seal. The position is locked by the adjuster lock nut so that when the supply starts to close, the exhaust starts to open, minimizing a null zone. The pilot is unbalanced during normal operating pressure. The pilot achieves balance when inlet pressure reaches its vent pressure. As inlet pressure is transmitted from the main valve inlet sensing tube, through the pilot supply port, and into the main valve dome chamber, positive loading is achieved on the main valve disc due to the 30% increase in the dome seal area relative to the inlet seat. As pressure increases, the load to close the main valve also increases. As inlet pressure continues to increase, pressure will reach the vent point where the pilot becomes balanced. Venting occurs at 97.3% of set point. When venting begins, the pilot will be in a balanced position. The main valve will be unbalanced and closed. As inlet pressure increases to set point, the main valve begins to open. Dome pressure has been reduced by the pilot to less than 70% of inlet pressure. The main valve modulates to a less than full lift position, proportional to the amount of overpressure. For example, if pressure continues to increase, dome pressure is further reduced to 50% of the inlet pressure, resulting in increased disc lift and increased flow. When full overpressure is achieved, the main valve will be in a full open position. The pilot has reduced dome pressure, which is now at 0% of inlet pressure. We'll now demonstrate the pressure paths as the pilot regulates pressure in the main valve dome. Inlet pressure has increased, so the dome must be vented to achieve balance. Note that the supply port is fully closed and the exhaust port is open, allowing dome pressure to escape through the indicated path. When inlet pressure decreases, the dome must be resupplied by the inlet, since the exhaust is fully closed. Notice the change in pressure direction. The pilot will regulate dome pressure inversely proportional to the increase in system pressure when the pilot achieves balance. The forces generated in the pilot from inlet pressure and dome pressure cause movement of the piston, which engages and disengages the supply and exhaust seals. The two separate pressure forces in the inlet and exhaust areas combine to equally oppose the spring force above. As inlet pressure continues to rise, the pilot will regulate dome pressure by venting the dome. If inlet pressure decreases, the pilot will close the exhaust and open the supply, increasing dome pressure to achieve balance. As the valve fully modulates at 10% overpressure and reduces dome pressure to 0, the main valve will be in a full open position. Let's look at a graph of the pilot operation. With the pilot unbalanced, inlet pressure and dome pressure will increase together until balance is reached. Balance is reached in the pilot, and the dome must be vented to maintain balance. Keep in mind that very little fluid is discharged through the pilot exhaust to bring the pilot into balance. In order to maintain balance, the pilot will either vent or resupply the dome chamber, with dome pressure inversely proportional to the change in inlet pressure. The graph now shows dome pressure reduced to 70% of inlet pressure. At this point, the main valve is balanced and its set point is reached. The main valve will now start to modulate. inlet continues to rise to 10% overpressure, reducing dome pressure to 0. As inlet pressure starts to decrease, the pilot increases dome pressure. Note that the main valve is still flowing during the overpressure span. As inlet pressure continues to decrease and when dome pressure increases to 70% of inlet pressure, the main valve will close. After closing, the pilot will be unbalanced, and inlet and dome pressures will mirror each other at pressures below the vent pressure. The area within the central diamond shape of this graph represents main valve modulation. The consolidated 39MV72 is the only modulating pilot valve on the market with an adjustable blowdown. It also features main valve seat tightness up to 98% and pilot seat tightness up to 97.3%, making this pilot valve the undisputed leader in performance and efficiency. These features combine to enable higher operating pressures, lower emissions, and less process loss.